Hello, this is not your chemistry tutor, and in this video, I will teach you about one of the most fundamental topics in chemistry, which is reaction stoichiometry. I said it's fundamental because you will encounter stoichiometry not just in general chemistry, but also in advanced chemistry subjects. For part 1 of this series, I will teach you how to solve basic stoichiometry problems. I also included some examples so you can practice some calculations. Of course, we start with the definition of stoichiometry. It is a section in chemistry that involves the quantitative relationship between reactants and products in a chemical reaction. So when we say quantitative relationship, we are talking about the amount of products and reactants in a chemical reaction. So stoichiometry answers questions like how much reactant is consumed in a reaction or how much product is formed in a reaction. And you will encounter these types of questions in our succeeding examples. The most common method in answering stoichiometry problems is the mole method approach. In this approach, the coefficients in a balanced chemical reaction are interpreted as moles. So I'm pretty sure you are already familiar with a balanced chemical reaction. In a chemical reaction, the substances on the left side are the reactants, and the substances on the right side are the products. The number before each reactant and each product is called the coefficient. And in mole method approach, the coefficients are treated as moles. So this means you have 2 moles of Fe2O3, 3 moles of carbon, 4 moles of iron, and 3 moles of carbon dioxide. So how do you read this reaction? That is, 2 moles of Fe2O3 react with 3 moles of carbon to form 4 moles of iron and 3 moles of CO2. So I want you to understand mole method approach by heart because this is the approach we will be using in all our problems about stoichiometry. Okay? Before we answer actual questions, here are the skills you need to answer stoichiometry problems. Number 1, balancing reactions. Sometimes your professor will give you a reaction that is not yet balanced. Always remember that in any stoichiometry problems, the reaction must be balanced. Number 2, dimensional analysis. You will need this in converting units. And number 3, mole concept, especially in converting mass to moles or the other way around, from moles to mass. If in case you are not familiar with some of these topics and techniques, don't worry. I made separate videos and you can check those videos using the links on the description box. Let's answer example 1. Given the balanced reaction, how many moles of water forms upon reaction of 2.5 moles of O2? So we are given 2.5 moles of O2. And we are looking for the moles of water that will form. So we will use the mole method approach. According to the balanced reaction, 1 mole of O2 forms 2 moles of water. So using dimensional analysis, we put 1 mole of O2 on the bottom and on top we put 2 moles of water. So moles of O2 will cancel and the unit becomes moles of water. And if you solve this, 2.5 times 2 divided by 1, this is equal to 5 moles of water. And this is the answer to the question. Example 2, given the same balanced reaction, how many moles of water forms upon reaction of 12 grams of H2. So this time, we are given mass of reactant, which is 12 grams of H2, and we are looking for the moles of product, which is water. If you are given mass of the reactant, the first thing you need to do is to convert this to moles. So from 12 grams of H2, convert this to moles of H2, and then using the mole method approach, you convert this to moles of H2O. So we start with the given 12 grams of H2. In order to convert this to moles, we need the molar mass of H2, which is given 2.016 grams per mole. That means 1 mole of H2 is equivalent to 2.016 grams of H2. So grams of H2 will cancel. Now you have moles of H2. And then using the mole method approach, so we look at the balanced chemical reaction. According to the reaction, 2 moles of H2 forms 2 moles of water. So you put 2 moles of H2 on the bottom, and on top you put 2 moles of water. So moles of H2 will cancel, and the unit becomes moles of water. And if you solve this in your calculator, this is equal to 5.95 moles of H2O. So this is the answer to the question. Our last example is example 3. Given the same balanced reaction, what mass of water forms upon reaction of 1.50 grams of O2? This time, we are given mass of reactant, which is 1.50 grams of O2, and we are looking for the mass of product, which is H2O. So we are given 1.50 grams of O2. The first thing you need to do is convert this to moles of O2. And once you have the moles of O2, you can use the mole method approach and convert this to moles of H2O. And then finally, convert moles of H2O to grams of H2O. So let's start the solution. 1.50 grams of O2. To convert this to moles, we will use the molar mass of O2, which is 32 grams per mole. So 1 mole of O2 is equivalent to 32 grams of O2. Grams of O2 will cancel. Now you have moles of O2. And then you use the mole method approach. According to the balanced reaction, 1 mole of O2 forms 2 moles of water. So you put 1 mole of O2 on the bottom, and on top you put 2 moles of water. So moles of O2 will cancel. Now you have moles of water. And finally, you use the molar mass of water, which is 18.016 grams per mole. 1 mole of H2O is equivalent to 18.016 grams of H2O. So moles of H2O will cancel, and the final unit is grams of H2O. And if you solve this entire conversion in your calculator, you will get 1.689, and the unit is grams of water. So this is the answer to the question.